Yo, what's up everyone? Welcome back to the channel. Today we're diving headfirst into the world of electric vehicles, or EVs for short. We're not just talking about how they look or what it's like to drive one. We're going all the way down to the nuts and bolts, breaking down the tech that makes these things tick. From the battery that holds all that juice to the motor that actually gets the wheels turning, we're going to explore what makes EVs unique, how their performance stacks up, and whether making the switch is right for you. So buckle up, because this is going to be a deep dive. All right, let's kick things off with the heart of any electric vehicle, the battery pack. This is where the magic happens, where the electrical energy that powers the entire car is stored. Think of it like the gas tank of a traditional car, but instead of gasoline, it's storing kilowatt hours of electricity. Now, these aren't your average AA batteries. We're talking about sophisticated systems, usually lithium-ion batteries, packed together in a massive array. These packs are designed not just to hold a charge, but to release it efficiently and safely, powering the car for hundreds of miles on a single charge. The size and capacity of the battery pack directly impact the car's range, kind of like how a bigger gas tank lets you drive farther before needing to refuel. A larger battery pack generally means more range, but it also adds weight and cost to the vehicle. Manufacturers are constantly innovating in this space, pushing the boundaries of battery technology. We're seeing improvements in energy density, meaning more power packed into a smaller space, faster charging times, and longer lifespans. One of the coolest things about EV batteries is that they can actually recapture energy through a process called regenerative braking. When you hit the brakes in an EV, the electric motor essentially reverses, acting as a generator and converting kinetic energy back into electricity, which is then fed back into the battery. This is a huge advantage over traditional gasoline cars, where braking just generates heat and wastes energy. With regenerative braking, EVs can squeeze more miles out of every charge, making them even more efficient. Of course, like any battery, EV batteries degrade over time, losing their ability to hold a full charge. But the good news is that battery technology is constantly improving, and the lifespan of these packs is getting longer and longer. Many manufacturers offer extensive warranties on their battery packs, giving you peace of mind for years to come. Plus, as battery technology continues to advance, we can expect even better performance, longer lifespans, and more affordable prices in the future. So, the battery pack is really the heart and soul of the EV experience. It dictates how far you can go, how quickly you can charge, and ultimately, how practical an EV is for your daily life. As battery technology continues to evolve, we can expect even more impressive ranges, faster charging times, and lower costs, making EVs a more compelling option for more and more people. Next up, let's talk about the muscle behind the movement, the electric motor. This is what converts all that electrical energy stored in the battery pack into actual mechanical energy that turns the wheels and gets you moving. Now, electric motors are incredibly efficient compared to their gasoline-powered counterparts. Internal combustion engines have all sorts of moving parts, friction losses and heat dissipation, all of which waste energy. Electric motors, on the other hand, are much simpler and more direct in converting electricity to motion. This translates to quicker acceleration, smoother power delivery, and overall a more responsive and exhilarating driving experience. One of the coolest things about electric motors is their instant torque. In a gasoline car, you have to wait for the engine to rev up and build power before you really feel that push. But with an electric motor, peak torque is available from the get-go, giving you that instant acceleration that pins you to your seat. It's one of the things that makes driving an EV so much fun, that immediate surge of power whenever you hit the accelerator. Electric motors are also much quieter than gasoline engines. You don't have the roar of an engine, the clatter of valves, or the whine of a transmission. It's a much more serene and peaceful driving experience, especially at lower speeds. This lack of noise pollution is not only more pleasant for passengers, but also a huge win for reducing noise pollution in urban environments. Another advantage of electric motors is their simplicity. With fewer moving parts, there's less that can go wrong, and maintenance is typically much simpler and less frequent compared to a traditional gas-powered car. No oil changes, no spark plugs, no timing belts to worry about, just regular checkups and the occasional brake pad replacement. Overall, the electric motor is a key component in what makes EVs so compelling. Their efficiency, performance, quiet operation, and low maintenance make them a truly viable and even superior alternative to traditional gasoline engines. As technology continues to advance, we can expect even more powerful, efficient, and compact electric motors to power the next generation of EVs. All right, so we've got the battery pack, the brawn and the electric motor, the muscle. But what about the brains of the operation? That's where power electronics come in, the unsung heroes of the EV system. Power electronics are essentially the control center, managing the flow of electricity between the battery pack and the electric motor. Think of it like the conductor of an orchestra, making sure all the different instruments are playing in harmony to create a beautiful symphony of motion. This system is responsible for converting the direct current electricity stored in the battery pack to the alternating current electricity that powers the motor. It also regulates the amount of electricity flowing to the motor, determining the car's speed and acceleration. One of the key components within the power electronics is the inverter. This clever piece of engineering takes the direct current from the battery and converts it into the three-phase alternating current that the electric motor needs to function. The inverter also controls the frequency of this alternating current, which is what ultimately determines the speed of the motor and, by extension, the speed of the car. But the inverter is just one part of the story. The power electronics system also includes things like direct current to direct current converters, which step down the high voltage from the battery pack to power the car's low voltage electronics like lights, infotainment, and climate control. Then you've got onboard chargers, which manage the conversion of alternating current power from the grid to direct current power to replenish the battery pack. All of these components work together seamlessly, constantly monitoring and adjusting the flow of electricity to ensure optimal performance, efficiency, and safety. And just like with the other EV components, the technology behind power electronics is constantly advancing. We're seeing more compact and efficient systems, faster processing speeds, and better thermal management, all of which contribute to improved performance, range, and charging times. So, while you might not see or directly interact with the power electronics system, it plays a critical role in making EVs the capable and sophisticated machines they are. It's the behind-the-scenes wizardry that orchestrates the entire electric driving experience. Okay, so we've covered the battery, the motor, and the power electronics, but there's one more crucial piece of the EV puzzle: charging. After all, you can't drive very far with an empty battery, right? Now, charging an EV is a different experience than filling up a gas tank, but it's becoming increasingly convenient as the infrastructure continues to grow. The most common way to charge an EV is at home, using a level 2 charger, which can typically fully replenish your battery overnight. These chargers plug into a standard 240-volt outlet, similar to what you'd use for an electric dryer or oven. They deliver a faster charge than a standard 120-volt outlet and are a worthwhile investment for any EV owner. But what if you're on a road trip or don't have access to home charging? That's where public charging stations come in. These are popping up everywhere, from shopping malls and restaurants to highway rest stops and dedicated charging plazas. And they're getting faster too. Direct current fast chargers, also known as level 3 chargers, can deliver a substantial charge in a fraction of the time it takes to fully charge at home, adding miles of range in just minutes. The charging connector you'll use depends on the specific EV you have and the type of charger you're using. The most common types are CCS and CHAdeMO for direct current fast charging and J1772 for level 2 charging in North America. Most EVs can use adapters to connect to different charging standards, so it's always a good idea to check compatibility before you plug in. Now, the charging experience itself is pretty straightforward. You simply plug in your car, initiate the charge using the car's interface or a charging network app, and the charger takes care of the rest. Many charging networks offer apps that let you monitor charging progress, locate nearby stations, and even pay for charging sessions right from your phone. As EV adoption continues to rise, we can expect the charging infrastructure to keep pace. Governments and private companies are investing heavily in expanding the charging network, making it easier than ever to find a charge when you need one. Wireless charging is also on the horizon. promising even greater convenience and further simplifying the EV ownership experience. So while range anxiety might be a concern for some, the reality is that charging an EV is becoming less of a hassle and more of a seamless part of daily life. So that's a look at the core technology that makes electric vehicles tick. From the battery pack to the electric motor, power electronics, and charging infrastructure, it's a fascinating and rapidly evolving space. EVs offer a unique driving experience with instant torque, quiet operation, and zero tailpipe emissions. And as battery technology continues to improve and charging networks expand, EVs are poised to become an even more compelling option for drivers around the world. Thanks for joining us on this journey through the world of electric vehicles. Stay tuned for more insights and updates on the latest in EV technology. Don't forget to like, share, and subscribe.